Okay, welcome everybody. This is a run through of the Combined Science Higher Chemistry paper that you did for your mock exam before Christmas. You need to get yourself a green pen out and make your corrections to your papers as you go through the video. Okay, question number one. Figure 1 shows the apparatus that can be used to electrolyze sodium sulfate solution using inert electrodes. It says 1A, hydrogen is produced at the negative electrode. Well, if you do the electrolysis of sodium sulfate, you don't get sodium at one electrode and sulfate at the other. Actually, it's just the same as doing the electrolysis of water. You get hydrogen at one electrode and you get oxygen at the other electrode. The first question says, describe the test to show the gas is hydrogen. Well, hydrogen burns with a squeaky pop. So the 2 marks, 1 mark was for saying add a lighted splint. So you're going to burn it. And the second mark was for saying it burns with a squeaky pop. Now, if you put down squeaky pop test, you got no marks. If you just said that it burns with a squeaky pop, you couldn't get the second mark without first getting the first mark. So you had to say that you had a lighted splint. The second part, what is the name of the gas that forms at the positive electrode? Well, we've already done that. That's got to be oxygen because it forms oxygen and hydrogen. State what is meant by the term electrolysis. Well, during electrolysis, you break down an ionic compound into ions, and those ions go to the electrode and form the elements that that compound is made from. So it's breaking down a compound using electricity is the simplest description of what electrolysis. So the first mark was for saying that it uses electricity. So using electricity to break down a compound. You could say to split a compound up into the elements that it's made from, or you could say to break an ionic compound into the ions that it's made from. Any of those were suitable answers. Part B says the sodium sulfate solution was made by dissolving 28.4 grams of sodium sulfate in water to make 250 centimeters cubed of solution. Calculate the concentration of the solution in grams per decimeters cubed. Give your answer to 3 significant figures. Now, you don't need to remember an equation for this. You're asked to remember the concentration in grams per decimeter cubed. Well, this tells you the calculation that you need to do. You need to divide the grams by the decimeters cubed. That is grams per decimeter cubed. So to work that out, it's the mass divided by the volume, the mass in grams divided by the volume in decimeters cubed. The problem is you've got a volume in centimeters cubed. So the first thing that you need to do is turn your centimeters cubed into decimeters cubed. Well, there are 1,000 centimeters cubed in a decimeters cubed. So you need to divide 250 divided by 1,000 equals 0.25 decimeters cubed, and then you just need to divide the mass by that. So you've got 28.4 divided by 0.25. Now that gives you a figure of 113.6 grams per decimeter cubed, and it says give your answer to 3 significant figures. So that's going to be from this side 1, 2, 3. So I need to round that up to 114 grams per decimeter cubed. And there was 3 marks for that, 1 mark for that, 1 mark for that, and 1 mark for the rounding up. The part C says the ions present in sodium sulfate are Na plus and SO4 2 minus. Well, sodium sulfate has to be a neutral compound. So if I'm going to write the formula, I need to use what's called the crossover rule. So the way that you would have been taught this, Na1 plus or Na plus 1, underneath it, SO4, and that has a charge of 2 minus. So the formula of sodium sulfate is Na2SO4. Now, the crossover rule is one way of doing it. The other way of doing it is to think, well, if I've got 1 plus and I've got a 2 minus, I'm going to need 2 of the 1 plus to cancel out the 1, 2 minus. However you do it, the formula then becomes Na2SO4. And remember, when you're writing the formula of a compound, even if it has ions that are charged in it, the ions combine in a way that the charges cancel each other out. So it's got to be neutral without any pluses or minuses on it. Question 2 says, the word equation for the reaction between copper carbonate and dilute sulfuric acid is copper carbonate plus sulfuric acid goes to give copper sulfate plus carbon dioxide plus water. Complete the balanced equation for this reaction. Well, all you're being asked to do there is to write the formula of sulfuric acid and the formula of copper sulfate. Now, sulfuric acid is hydrogen sulfate. Sulfuric acid is used to make sulfate salts, and it's the hydrogen version of sulfate. So it's hydrogen sulfate. Now, you were given the formula of the sulfate ion in question 1, and that is sulfate is SO4 2 minus. Well, if hydrogen is going to come before that, hydrogen is H plus. So I'm going to need 2 hydrogens to every SO4 2 minus. And so the formula of sulfuric acid is H2SO4, which you should probably know anyway. And that goes to give copper sulfate, which is just CuSO4. So I've got H2SO4 for sulfuric acid and CuSO4 for copper sulfate. Part 2 says calculate the relative formula mass of copper carbonate. Well, copper carbonate contains copper times 1, it contains carbon times 1, and it contains oxygen times 3. So it's 1 times copper, which is 63.5, 1 times carbon, which is 12, and 3 times oxygen, which is 3 times 16. Now, if you do all of those, you add them together, you get 123.5, which is the answer. And the last one says, what is a chemical test to show that the gas is carbon dioxide? Well, second question, you got the second gas test. There's only 4 gas tests. You've had 2 of them already this test. Carbon dioxide, when you blow through lime water, it goes cloudy because of the carbon dioxide in your breath. So the test for lime water is to bubble the gas through lime water and it goes cloudy. So the answer is A. Part B says figure 2 shows a conical flask containing dilute sulfuric acid. Copper carbonate is added to the flask. The copper carbonate is added 1 spatula measure at a time until the reaction has finished. So state 2 observations that show that the reaction has finished. So if you add copper carbonate into dilute sulfuric acid, it will produce carbon dioxide. So it will fizz all the time that the acid is reacting. But when the acid has been used up and the reaction is finished, then it will stop fizzing. So the first and easiest answer was to say that it has stopped fizzing. And that was the easiest one. The next one, you will get a color change when you add copper carbonate to dilute sulfuric acid because it makes copper sulfate, which is blue. And so it will no longer change color. So it stops changing color. Would be another way. And also, if you're adding excess copper carbonate, then it will also go cloudy because you'll see unreacted copper carbonate. So either saying that you get unreacted copper carbonate or it goes cloudy would be also a mark. So we'll put that in as well. Cloudy stroke unreacted. Unreacted carbonate. Now, C, it says the electron configuration of carbon is 2.4. The electronic configuration of oxygen is 2.6. Draw a dot cross diagram of a molecule of carbon dioxide. Show the outer electrons only. Now, carbon dioxide is CO2. It's going to have 1 carbon and 2 oxygens. So I'm going to have carbon in the middle and I'm going to have oxygen either side of it. There was an amazing amount of people who didn't realize that. Once you've done that, then carbon has got 4 electrons in its outer shell and oxygen has 6 electrons in its outer shell. The only way that you can get them both full is if they share 2 pairs of electrons each. So it's a double bond. It's actually C double bond O, C double bond O for carbon dioxide. And you will have done that as one of your examples. So a double bond is 4 shared electrons. So I've got 2 electrons from my carbon and 2 electrons from my oxygen in each bond. So that is my double bond, like so. Now that means that carbon has now got its 4 electrons because it's got either 4 dots or 4 crosses. Let's say carbons are crosses. So that's my 4 electrons from carbon, but by sharing 4 electrons from oxygen, it's as if carbon has got 8 electrons in its outer shell. Now all I need to do is make sure that each oxygen has 8 electrons in its outer shell, including the ones from carbon, and that it's actually got 6. So if I'm drawing the oxygen as dots, it's got to have 4 more with the 2 that are there. If 6 and sharing 2 gives me 8. So it's going to be like that. Now you've got 2 marks. You've got 1 mark for getting the 2 double bonds, and you've got 1 mark for drawing the other electrons on the oxygens. Question number 3 says a sample of rock salt contains a mixture of sodium chloride and some insoluble substances. The rock salt is added to water and the mixture stirred. The mixture is then filtered to obtain a filtrate of sodium chloride solution. Draw a labeled diagram of the apparatus used to filter the mixture and collect the sodium chloride solution. Now you've got 2 marks for drawing the filtration equipment. You're going to need a filter funnel, which you have to draw like this, and you can't draw closed off at the end. So that's my funnel. In that, I put a piece of filter paper, and I'm going to filter that into either a beaker or a conical flask. It doesn't matter which. So you got 1 mark for drawing those 3 things, and the second mark was for labeling them. This is filter paper. This is a funnel. You can call it a filter funnel if you want, but funnel is fine. And this is a beaker. So the second mark was for labeling those 3 things like that. That was a really easy 2 marks, one that you should be kicking yourself for if you didn't get that. Describe how a simple, pure, dry sodium chloride crystals can be obtained from the filtrate. Well, the filtrate is sodium chloride solution, sodium chloride dissolved in water, and I want to get sodium chloride crystals. So I need to evaporate the water off. Now that process is called crystallization, and if you said crystallization, you got 1 mark. But ideally, you want to say what the process of crystallization is. So and your course is very clear about crystallization. You need to heat in an evaporating basin to evaporate the water. You will have done this. I'll draw it out here. You didn't get any marks for the drawing, but this is an evaporating basin and a gauze and a tripod, and you heat your sample with a Bunsen burner to evaporate off the water. But your course is very clear about you don't evaporate the solution to dryness. So you got 1 mark for saying heat the solution to evaporate. The second mark, if you remove half of the water, the key thing is you don't heat it to dryness. So you concentrate it and then cool the solution to form crystals. Isolate the crystals, and you can do that either by filtering them again or damping them dry with filter paper. Isolate the crystals and then dry the crystals in an oven. You could also say leave the solution in a warm place to crystallize and to get crystals. But what you mustn't say is that you just heat them to get the crystals. That, I think, will get you the marks there. Part B is all about chromatography, and it says samples of 4 inks W, X, Y, and Z were separated using paper chromatography. Figure 3 shows a chromatogram obtained. In the experiment, the solvent front moved 6.5 centimeters. Calculate the RF value of the dye that is present in both inks X and Z. So that is this ink here. That ink there. Now the RF value is a fraction. It's a number between 0 and 1, and it's the ratio of how far the substance moved divided by how far the solvent moved. So it's always the smaller number divided by the bigger number, and that's always going to give you a fraction, a number between 0 and 1. Now, according to the mark scheme, it was 3.9 for the dot and 6.5 for the solvent front, which give you a value of 0.6. The second bit says, state what you could change in the experiment to make the RF value more accurate. Well, accuracy, if you use a larger piece of paper, you're going to be measuring bigger values. And if you measure bigger values, they're going to be more accurate. So the best answer was a longer chromatography paper, so longer chromatography paper. In this experiment, ink sample Y did not move from the start line. Explain a change in the experiment which would be needed to separate the dyes in ink sample Y. Well, the reason that Y didn't move is because it was insoluble in the solvent. So you need to change the solvent. I did allow solution. Change the solvent so that the ink will dissolve. And that's quite an easy 2 marks. Question number 4 says titanium and iron are examples of transition metals. Figure 4 shows the percentage abundance of each isotope in a sample of titanium. Well, you got 1 mark for reading correctly the percentages off the graph, and they were 8, 7, 75, 6, and 4. So you've got 8% of 46 plus 7% of 47 plus 75% of 48 plus 6% of 49 and 4% of 50. And if you do that calculation and add all of those up together, you get, I'll tell you the numbers, you get 368 plus 329 plus 3,600 plus 294 plus 4791 divided by 100, which gives you 47.91. Sorry, that should have been 294, 200. This was 200. And the total gives you 4791, which is divided by 100. 47.91 was the answer. Really, that's quite a straightforward 3 marks, I think. Part B says iron, when heated in air, reacts with oxygen to form iron oxide. The reaction is an example of, most of you got this, the answer was oxidation. And part 2 says the equipment shown in figure 5 can be used to find the mass of oxygen that combines with iron. Describe how the experiment shown in figure 5 could be used to find the mass of oxygen that combines with 5 grams, 0.5 grams of iron wool in a crucible and lid of known mass. So I know how much iron I've started with. I know how much the crucible and the lid weighs. I then have to just heat the iron for 10 minutes actually I've got to heat it. What it will do is it will increase in mass as the oxygen adds to it. And I've got to heat it. You've got a mark for saying that while you heat it, you've got to open the lid to allow the oxygen to get in. And you heat it until it's constant mass. So that was one way of getting the mark. So heat, open lid a little, heat to constant mass. So you heat it until it doesn't increase in mass anymore, and then you subtract, you weigh it again, weigh at the end of the experiment. So you weigh it at the end of experiment, and it will have increased in mass. So you can find the mass of oxygen. The mass of oxygen is the increase in weight. So you take the final mass and you subtract the original mass from the final mass, and that will give you the mass of oxygen. Now, there were 4 ways there that you could have got the 3 marks, and any 3 out of those 4 would have got new full marks. Part C says 2.24 grams of iron combines with 0.96 grams of oxygen to form iron oxide. Determine the formula of iron oxide and use it to complete the balanced equation. Well, the formula is the simplest ratios of moles of the elements in the compound. So you need to find moles. Moles equals grams over rams. Relative atomic mass. So you take the grams, divide it by the rams, and then work out your ratios from there. So iron is 2.24 divided by the RFM of iron, which is 56, and oxygen is 0.96 divided by the RFM, which is 16. Now, if you do that, you get 1 to 1.5, which is in the ratio of 2 to 3 in whole numbers. So my ratio of moles of iron to oxygen is 2 to 3. That means the formula of my iron oxide is Fe2O3. And you got 3 marks out of 4 for getting as far as that formula, Fe2O3. Now, if I'm going to make Fe2O3 here, then I obviously need 2 lots of iron and 3 lots of oxygen, but I can't make 3 lots, so I'm going to have to make 6 lots. So I put a 3 in front of there, that gives me 6. And I'm going to need 4 Fe. And I make 2 lots of Fe2O3. So the final mark was for getting the ratio 4 to 3 to 2. Question 5a, calcium has an atomic number of 20, so it's going to have 20 protons. It has a mass number of 40, so it's also going to have 20 neutrons. So the answer was A, 20 protons and 20 neutrons. Explain using the information in Physics 6 in which period of the periodic table calcium can be found. Now, calcium has got 1, 2, 3, 4 shells. It's got 2 electrons in the outer shell, but it's got 4 shells. Now, the number of shells tells you which period it is in. Many of you put down that it is in period 2 because it's got 2 electrons in its outer shell. Well, it isn't. It's in group 2 because it's got 2 electrons in its outer shell. The groups are the columns in the periodic table, the periods are the rows, and each row is where a new shell starts. So I have 2 elements in the first shell. I've then got 8 elements and 8 elements, and that's because of the way that the periodic table is arranged. So it's 4 shells, so it's in period 4. So period 4 because it has 4 shells with electrons in, or 4 occupied shells, so it's in period 4. Part B says calcium and potassium react with water in similar ways. One similarity in the reaction is that hydrogen is produced. State one other similarity in the products of the reaction of calcium and potassium with water. Well, there is only one other thing that is produced. They produce calcium reacts with water to give calcium hydroxide and hydrogen, and potassium reacts with water to give potassium hydroxide and hydrogen. So the other similarity is that they produce the metal hydroxide. Now you really should, considering that you've just learnt topic 7 where you did the reactions of group 1 metals, you should have known that. So they produce the metal hydroxide. Produced. And the next one, potassium is higher in reactivity series than calcium and reacts more vigorously with water than calcium reacts with water. State why potassium is higher in reactivity series and reacts more vigorously with water than calcium. Well, how reactive a metal is to do with how easily it loses electrons. So potassium loses its 1 electron easier than calcium loses 2, actually, but as long as you said that potassium loses electrons more easily, potassium loses electrons more easily. And many of you went on to say that it was because the electron was further from the nucleus and things like that, but that's all you needed to say to get the mark. Now, the 6-mark question, part C. Calcium chloride can be prepared by the reaction of calcium with chlorine gas. Figure 7 shows some properties of calcium, chlorine, and calcium chloride. Now, the question is all about structure and bonding and the effect that the structure and bonding has on the properties. And the question says, explain in terms of bonding and structure why the properties of the product, calcium chloride, are different from the properties of the reactants, calcium and chlorine. Now, you're given a table of results, and many of you were able to interpret the table of results, but unfortunately, you don't get any marks for saying, calcium has a high melting point. You've got to say what the bonding and structure is in calcium. You've got to say what the bonding and structure is in chlorine, and you've got to start off with the bonding and structure in calcium chloride. And then you need to use your description of the structure to explain the properties. Now, we start this off with calcium. Calcium is a metal, chlorine is a non-metal, and calcium chloride is a compound that is made between a metal and a non-metal. Therefore, it's going to be an ionic compound. So let's just make this a little bit bigger. Calcium is a metal with a metallic structure. Chlorine is a non-metal with a simple covalent structure, and calcium chloride is an ionic compound. So if you remember back to topic 2, there are 4 main types of structure. I've got ionic structures, simple covalent, giant covalent, metallic. I've got 3 of them here. And what I need to do, I've named them. I get 2 marks so far for naming each of the 3 structures. I then have to describe what the structure is like. So calcium chloride is an ionic compound. It consists of calcium ions, Ca2 plus and Cl minus ions held together in a lattice by strong electrostatic attractions. It has a high melting point as a large amount of heat is required to overcome these attractions. Now, in terms of its conductivity, it says that it is calcium chloride is a poor conductor when it's solid, but a good conductor when it is molten. So it conducts electricity because the ions can move, not electrons. This is ions. It's an ionic compound. In the solid, the ions are fixed in the lattice, so it can't conduct, but when molten, they can move, so it can conduct. Right, that's everything that I need to say about calcium chloride. Calcium chloride is an ionic compound consisting of ions, high melting point, doesn't conduct when solid, conducts when molten. Now, many of you, that's just knowledge that you have been taught and that you should be able to recall. Many of you said things like calcium chloride is in between calcium and chlorine, or it's got some properties of calcium and some properties of chlorine. And, it's just not enough technical detail, not enough accurate descriptions. In all of these questions on structure and bonding, you need to describe the structure. You need to have a really good picture in your head of what the structure is, and you need to be able to describe it. And then you need to use that description of the structure to explain why it does the things that it does. Why does it have a high melting point? Well, because the ions are held together strongly. You can't say because the electrons, because there aren't free electrons, or Why does it conduct electricity? Because the ions are free to move. So that's calcium chloride. Chlorine is a diatomic. That means it has 2 atoms molecule. And the formula of chlorine is Cl2. Strong covalent bonds between atoms and weak intermolecular forces so those weak intermolecular forces between the molecules mean that it has a low melting point. So weak intermolecular bonds between molecules means it has a low melting point. And it can't conduct electricity. No free ions or electrons, so can't conduct. Electricity. And the last one is calcium. Calcium metal contains Ca2 plus ions in a sea of delocalized electrons. In a sea of delocalized electrons. Now, that's my picture that I've got in my head. The reason that it has a high melting point is that there are strong electrostatic attractions, strong electrostatic attractions between ions and sea of electrons means high melting point, and it can conduct because electrons can move through the structure. So in metals, it's the electrons in the sea of electrons that can move through the structure. Now, that really, for 6 marks, wasn't difficult. If you know your stuff, then you can describe the structures, the 3 structures that you've got, 3 out of the 4 that you were taught, and then you can use that structure to explain the properties. The problem is that you're going into that and you don't know your stuff well enough, and you're trying to just explain the numbers that you've got in the table without the proper understanding of the structures, and as a consequence, you're getting quite poor marks. So just make sure that you know your structure types and you can use the structure type to explain the properties. Right, question 6, the last question was all about acids. It was quite a tricky question and it was poorly answered in general. Explain why dilute hydrochloric acid is described as a strong acid. Well, okay, it's got a low pH, but that doesn't make it a strong acid. Concentrated acids have a lot of hydrogen ions, and weak acids don't have many hydrogen ions because they're diluted down. But strong and weak is different. Dilute hydrochloric acid is a strong acid because it fully dissociates. So every hydrogen chloride, HCl, splits up into a hydrogen ion and a chloride ion. So it produces lots of hydrogen ions. Now, you could have got 1 mark out of 2 if you said it produces lots of hydrogen ions. But the reason that it produces lots of hydrogen ions is that it fully dissociates. Dissociates means splits up into ions. So it fully dissociates splits up and so produces lots of hydrogen ions, H plus. Well, that would have got you the 2 marks. 1 centimetre cubed of hydrochloric acid with a pH of 2 is made up to a volume of 10 centimetres cubed. So it's diluted down by a factor of 10 with distilled water. State the pH of the new solution. Well, changing the concentration by a factor of 10 changes the pH by 1. But you've got to get them round the right way. Now, if it's more concentrated, the pH is going to be lower. So if it's an acid, if it's more concentrated, the pH is going to be lower. So the most concentrated acid. So if I've got 1 centimetres cubed of a concentrated acid and I'm adding water to it, it's going to increase the pH because it's going to be less acidic. So if I start off with a pH of 2, I dilute it down by 10, I'm going to change it by 1 pH unit, but it's going to increase by 1 pH unit. So the pH is going to be 3. The ionic equation for the reaction of magnesium oxide and hydrochloric acid. There was 3 marks for this, and it is quite involved. Now, you're not given much space to do your work in, but the steps to writing an ionic equation is if the material is soluble and ionic, then you split it up into the ions that it contains. You then cancel out the spectator ions, and you're left with the equation that you need. So I'm going to try and squash that in here. If we look, so the first thing that I want to do is split the ionic things up into ions. Well, the ionic things are magnesium oxide, hydrochloric acid, and magnesium chloride. Water, H2O, is covalent, so it's not, I don't have to split that up. But I don't have to do magnesium oxide because that's a solid, it's not in solution. So the 2 that I have to split up are the HCl and the MgCl2. So I get MgO plus 2H plus 2Cl minus. That's splitting HCl up into the ions it contains. Each HCl contains H plus and Cl minus, but I've got 2 of them. That goes to give MgCl2, which is Mg2 plus 2Cl minus plus H2O. Now all I do is I cancel out any spectator ions, the ions that are the same on each side, which in this case is the Cl minus, and I get MgO plus 2H plus goes to give Mg2 plus H2O. And that was 3 marks. You got 1 mark for the left-hand side, 1 mark for the right-hand side, and 1 mark for balancing. But really, it's just following a method. You just learn the method and then write it out. The next bit was quite a bit easier. In an experiment, but a universal indicator paper was used to test the pH of the solution after each addition of magnesium hydroxide. Give the name of an alternative piece of equipment that can be used to measure pH. Well, a pH meter, or you could also call it a pH probe, is just an electronic meter that you can put into a solution, and it digitally measures the pH of the solution. The last part, part C, says state and explain how the pH changes as magnesium hydroxide is added to dilute sulfuric acid. Well, to answer this was quite poorly answered. How does the pH change as magnesium hydroxide is added to acid? And it says explain, state and explain. So the pH of the acid is going to be low, first of all, 1 or 2. And then as you add magnesium hydroxide, the pH is going to increase. Now, that's what's going to happen. The pH is going to increase. It's going to get to 0 when it's neutral. But then if you keep adding magnesium hydroxide is an alkali, so it's going to increase above 0. Now, you got 1 mark for saying that the pH increases. And another mark for saying pH above or equal to 7. Okay, so the pH increases to 7 and it will increase above 7. Now, the reason for that is that it's a neutralization reaction, and the OH minus ions from the hydroxide react with the H plus ions from the acid. So neutralization, and the H plus ions from the acid react with the OH minus ions from the hydroxide. So the hydrogen, the H plus ions reduce in concentration, and the OH minus ions increase in concentration. So what happens is you've got lots of hydrogen ions, you're adding hydroxide ions, they react first of all to make water until eventually all of the hydrogen ions have been used up, and then you're going to add OH minus ions, and so the OH minus ion concentration increases. So really, I don't think anybody got over a couple of marks for saying that the pH increases, and that reason why is because of the ions that are in the acid and the ions that are in the alkali. Right, that's it. That's the end of the paper. Thank you for correcting those. Hopefully you found that process useful.